Yes, this is Dr.Senthil Kumar, Associate Professor, Department of EEE, SNS College of Technology. Our course is Analog Electronic Circuits 23 WT 104. We are sailing in the power amplifier topic, unit number 3, whereas we are going to discuss about transistor as an amplifier. Transistor as an amplifier. We studied about the characteristics of transistor, where there are three regions. One is active region, the second one is saturation region, and the third one is cutoff region. Whereas for a transistor acting as an amplifier, it should be operated in, or it should be properly biased in active region. The other two, you mean the saturation and the cutoff region, is for transistor acting as a switch. Whereas here, transistor is acting as an amplifier, therefore the transistor should be operated or should be properly biased to work in active region. Now see, in the left hand side, the transistor symbol, a transistor 3-pin configuration transistor is shown here, whereas here we are going to discuss about transistor as amplifier. The power amplifier. Transistor will act as an amplifier, whereas normally it is an voltage amplifier, whereas it amplifies a small signal into a larger signal. Whereas a power amplifier is capable of producing a large amount of power from a small load, right? Normally, this type of amplifiers, a power amplifier, will be in the last stage, of any circuit. The important features may be the impedance matching. It is used for the impedance matching purposes, and it also produces, due to its non-linear characteristics, it also produces harmonics. And this may be the drawback of an power amplifier, whereas it is particularly used for impedance matching of the electronic circuits. Now let me see the transistor circuit. Before going to the transistor circuit, the power amplifiers is classified into Class A, Class B, Class C, Class AB, and Class D. All these configurations depends on how the output waveform appears from the input. Suppose if the input waveform is AC sinusoidal and the output is also remains the same full sine waveform, then it may be Class A. Suppose the output waveform is only positive off cycle, then it may be Class B. Suppose the output waveform is less than positive off cycle, it may be Class C. But depends on the output waveform, how the output waveform is measured or shown, depends on it. The amplifier is classified as A, B, C, and D. Right? The right hand side shows the circuit diagram. The PCB board, where a transistors, capacitor, resistors, and potentiometer comes into the picture. Now let me see a power amplifier Class A type. We discussed in the previous video about the operation of an amplifier, operation of a transistor as an amplifier. The same, whereas apart from the same circuit, AC sinusoidal input is given in the left hand side, and a coupling capacitor C1, R1 and R2 is acting as a base biasing resistors for the transistor acting in a active region. R is a emitter resistor, and C is a emitter capacitor for stabilizing purposes, and RC or RL is the load resistor which is connected in the collector terminal of a transistor. VCC is the plus supply voltage and ground is your DQV, right? And here the transistor is not operated in cutoff on saturation region. It is active. It is operated in the active region with the help of resistors R1 and R2. Therefore, the output, if the output is AC sine wave form, positive plus positive is the first and the negative second, then although the transistors were acting as an amplifier, it also inverts the output waveform. See, the input positive is the first, whereas in the output negative is in the first. You mean 180-degree inverted, right? This is shown with the help of an load line characteristics. The load line characteristics is in the red color, which is 45-degree tilt. In the output characteristics of a transistor, Q point is the center point or operating point, or is also said as quiescent point, where it acts as an x-axis. The input signal is shown below the x-axis and the output is almost in the y-axis. Output signal, it is amplified and it is also inverted. Hope you understand the operation of a transistor in the previous video. The same explains here, and hence the small signal is amplified and it is also inverted. Thank you for patient listening. Thank you.